This video is going to go over the exercise in Khan Academy with the title Tangents of Circles Problems. And this practice was assigned to you on week 4 of distance learning. Let's look at the first question. The first question says that line AC is tangent to circle O at point C. What the word tangent means is that this line touches the circle at one point, and that point is point C, and it intersects point O at this point of tangency. The question is asking us what the measure of angle ACO is, which is ACO, which is this angle right here. Now, what do we see in this angle? I see that this angle is from a tangent line. Let's make that a little bit better. It's from a tangent line intersecting a radius. Now, one thing we know about a radius and a tangent line intersecting is that they always form a 90-degree angle. So that means that angle C is 90 degrees. Will always be 90 degrees at the point of tangency. So let's type that in and check our row. Let's try another problem. All sides of quadrilateral ABCD are tangent to circle P. So we've got circle P right here, and we've got this quadrilateral around the circle. The question is asking us to find the perimeter of the quadrilateral. A perimeter means that you have to add all the sides and find its measurement. So let's look at the problem. Let's dissect it one by one. Let's say that I am trying to find this line right here. What do I notice? One thing that I see is that this yellow line and that this other yellow line both are connected to this external point B. One rule about tangent lines coming from the same external point is that they are congruent. That means that if this is 3.3, this missing side will also be 3.3. Okay? All right, let's see what else we can figure out. The other thing that is missing right now is the measure of this line. But I don't think we can get to that until we figure out how long each segment is. So let's go one by one. If this segment is 5.1, then we should know that this segment is also going to be 5.1. And the reason for that, again, is that these two green lines are being connected to the circle from the same external point, point C. So they will be congruent. Now, if this whole line is 12.1 and we already have 5.1, we can easily figure out how much is missing. So we can set up the equation 12.1 minus 5.1, and that is going to give us the length of 7. So this pink segment is going to be 7 units long. Now, if this is 7 units long and it's a tangent line, and there's another tangent line from this same external point, and that means that this segment is also going to be 7 units long. Now on this side of this quadrilateral, if the whole segment AD is 12.2 units long, then we will be able to find the measure of this segment. Again, the whole thing is 12.2, and we already have 7. 12.2 minus 7 is going to give us 5.2. Now, if this segment is 5.2, then the other segment will also be 5.2. I'm going to clean up the drawing a little bit, get rid of all unnecessary measurements to make it clearer for us when we add everything to find the perimeter. Okay. Okay. So now we have all the measurements that we need to be able to find the perimeter. All we got to do now is add all of these up. So let's start with this small segment. We've got 5.2 plus 3.3. 5. Actually, let's put this in red. 5.2 plus 3.3. Moving around, we've got 3.3 and 5.1 plus 3.3 plus 5.1. And let's look at this whole line now. We are given that this whole segment CD, is 12.1. So plus 12.1 plus the last segment AD as a whole, is given to us as 12.2. So what I'm going to do now is I'm going to take out my calculator and plug in these numbers. 5.2 plus 3.3 plus 3.3 plus 5.1 plus 12.1 plus 12.2 will give us sorry about that. Will give us 41.2. I exited it by accident and I finally got it back. So 41.2 is the sum, which is the perimeter. Let's look at the next question. All right. Line AC, this line, is tangent to circle O at point C. Again, remembering that what tangent means is that this line is touching the circle at one point. What is the length of line AB? So we are going to be looking for this right here. Okay, so that will be our unknown. Because we are looking for length, and because I know that tangent lines and the radius form a 90-degree angle, what I'm thinking is that we can use the Pythagorean theorem to find the missing side. So let's go ahead and set that up. Pythagorean theorem says that a squared plus b squared is equal to c squared. All right. So A and B are going to be the sides of your triangle. Let's say that the base is A. So we're going to have 24 squared. Ooh, this is going to be a big number. Plus B is the other side, which in this case is the height. 7 squared. Oops. Let's make sure that we are consistent with our colors. is equal to c squared, which is this whole hypotenuse, which right now we don't know what it is yet. So we're going to leave it as c squared. Okay? So what I can see is that we can simplify these two numbers. So let's start with the first one. 24 squared is simply 24 times 24, which is going to give us 576. 576 plus 7 squared is simply 7 times 7, which is going to give us 49. And that is equal to c squared. Now these two numbers we can combine. 576 plus 49 is going to give us 625. And 625 is going to equal c squared. Now the last thing we have to do is we have to get rid of this exponent of 2. Some students might say that we should divide by 2, but the only way to get rid of a power of 2 is to take its square root. The opposite of operation of raising to the power of 2 is taking its root. So now that the exponent of 2 has canceled, we now have c being equal to the square root of 625. And the square root of 625 is 25. Because 25 times 25 will give you 625. Now the question is that what the question was asking? Now if this whole blue thing is 25, as you can see by what I marked here, we are only looking for this yellow part. Now how do we find that? Now if this whole thing is 25, but part of it is a radius. See here, this is a radius. And remember, all radii are equal. If this part is also 7, then what is missing to get the complete 25? The last thing we're going to do then is to take that 25 and subtract the 7 we already have. So we've got 25 minus 7, which is going to give us 18. So that means that segment AB, this yellow segment, is 18. Okay, let's do one last question. Angle A is circumscribed about circle O. That means that angle A right here is right outside the circle. We are being asked what the measure of angle O is. Now, what do I know about tangents of circles? I know that tangents of circles make up 90 degrees with a circle's radius. So this is 90. This is also 90. What else do I see? I see that all these 4 angles make up a quadrilateral. And if you remember from old lessons while we were still in class, quadrilaterals have a total angle sum of 360. 360. Now to find what angle O is equal, all we gotta do is subtract all the known angles from 360. So we already have 70 degrees, which was given to us. And we've got 90 degrees, which we know because tangent line intersecting with a radius will always form a right angle. And we got another 90 degrees right here. And whatever is missing will be the measure of angle O. So let's go ahead and solve this. 360 minus 70 is going to give us 290. 290 minus 90 is going to give us 200. 200 minus 90 is going to give us a final difference of 110. That means that this angle is 110 degrees.